were smoother. I think it's last day we had a lot of terminology, which is the hardest thing to remember. You're not really applying things, so either you know the definitions or you don't. All right? And it was a long weekend, so it's not the best time to take it, but we're in a quarter system, so we just keep on moving. It's an unfortunate situation. So before we begin, this is a road sign, and the question is, does this add up?
Can't you just add it?
And yeah, so that's my question. Does it add up?
Does it? Probably. 3.
Yeah, I would say so.
I don't know.
Wait, no.
No.
Calculator.
No, it doesn't. No, the last number's wrong. It should be 3 instead of 4.
It is a 3.
I think it's right.
The last one.
Like the first
The last
or the
one.
first number.
First
I
number.
think it's right because you remember when you go
No,
to
it's right.
school,
Yeah,
it's
it's
like
right.
that, not 9.
All right.
It's right.
Is it right?
Yes.
No.
I did all the math in my head, Mr. Doyle.
What should, I see everybody saying it's right except for Sadie.
Okay, I can't do math, so I think it's right.
Like, we can grab our calculators.
Yeah, no, it's not.
Mr. Dollywall, you know very well if it's right or wrong.
Mr. Dollywall, my 6th grade teacher.
Can't you just start with questions?
There's a reason why Mr. Dollywall is showing you this, right? There's got to be a reason.
Watch us just like subtract 4,663.
All right?
Read it carefully.
So, one of the things that they want you to do in math is not just take numbers and be able to do arithmetic, right? But make sense of the numbers. Okay? So, if we add these numbers, yes, it does equal 4,663. What does this number down here represent? What are we adding? What does this equal? What does this mean? What
It's
does-
just a number because it's not the population, it's not sea level, and it's not when it was established.
Yeah.
It's established in just a year.
It's a year. So there is no reason to add these up.
Yeah.
Why
And
did
this
they?
is a nonsense number.
Yeah,
Why did they
exactly.
add it up?
I don't know why they added it up. Because you shouldn't be adding it up, right? Because that final number doesn't mean anything, right? So this is an actual town in California. It's a small town in, I think, I forget whereabouts in California.
Population.
Yeah.
What does
Yes.
population feet above sea level and establish? I don't know that word.
Establish what when it was created, the town.
Okay, but like, why does it need to be all added up like
That's
that?
what-
It shouldn't be. That's the whole point,
It's kind of funny that it's just a
Sorry, I don't know.
coincidence.
right?
It's just a coincidence.
What do you mean it's just a coincidence?
No,
Because
that it
they're
adds
making
up.
us do math.
No.
It's just a coincidence.
No,
that
they
it adds up.
added it up though.
They actually added it up.
Oh,
The town added it up,
There
and they
is
should
no
have,
coincidence. They just added it.
right? That total means nothing.
when the teacher said,
But they did.
Alright.
add question.
So it only makes sense to add things up that are of the same thing, right? You're adding up all fruits. It doesn't make sense to add fruits and boxes, right? Like that. What would that number mean?
Well, you might be able to find out how much fruit you can put in a box.
Depends on the context, right? Or fruits and cars, or something like that, right? When you're adding, they have to be of the same, all right? So that goes into today's lesson. All right, so today we're looking at expressions, and expressions are made of terms. Those terms can be either alike or unlike. And we'll get into a definition of what alike is and what unlike is. But like things, like the sign, is when we can add them up. Unlike is when we can't combine them. All right? So an algebra expression is made of terms. And those terms are separated by plus and minus signs when you're writing it out. Right? And each term can have any number of variables. Right? Those are the letters, the x's and y's. But it also could have no variable. So if it has no variable, what do we call that? Do you remember what it's called if you don't have a variable?
No.
A constant term. So that would be something like the number 7 or 9. Right?
Write any number?
Any numbers, right? Could be positive, could be negative, right? Now, each variable has an exponent. Right? It could be a 1, it could be a 0, it could be
How is
562.
It a 0? If it has a 0, does it mean it's a 0?
it's 0, yeah. Okay.
Wait,
So
But some of them don't have.
How come if there's just like a variable and it has like no exponent, that means it has 1.
yes.
How come if it has a 0, it has 0? Why don't they make that a 0, and if it has a 1, that means 1?
Do you remember what
Why does it
an
have-
exponent 0 means from the first term?
Oh,
It means it equals anything with the power 0, exponent 0 equals 1. So, right? Okay. Now, like terms, right, are the terms with the same variable. Not necessarily just only the same variable, the same variable raised to the same exponents. So if the variables are not identical, we don't consider them like. For example, 7x and 3x. The variables are x's, and they both have the same exponents. So these are considered like. The coefficients out in front of the variables don't make a difference. Right? It's the variables that we're looking at. Or 7w squared and 3w squared. These are like. We have a w with an exponent 2, w with an exponent 2. So those are like. Yes, Chloe?
So as long as they have the same variable and exponent, they're like?
Yeah. And remember, a term is not limited to just one variable. We could have, say, x and w combined. So long, and I've been using 3, but how about if I just did this? This is still the same thing. There's just an imaginary 1 in front of it. Right? The variable x to the exponent 1 with a w with the exponent 2. That makes them alike. Right? And the final combination of a term is you can actually have no variables. So something like 7 and 3 are considered like terms as well. Right? So all those are considered like terms. So I have a list of a whole bunch of examples here. Just on the side, example 1. Let's do these together here. Looking at question 1, it says circle. How about we just underline and we'll cross out the ones that are like, just to make it a little bit easier to see. So looking at here, first question A,
None of them.
which ones are like? So which ones have the same exponent to the same?
X and Y, the first two.
So no, that's a x and that's a y. Those are different.
The 2 Y's and 2 X's.
So that's,
No,
there's
none of
no
them. None of them.
None of them?
negative X maybe.
There's a negative x, and what is that same
first
as?
one?
But that,
And the first one, yeah.
Wait.
So
why?
both of them are x's to the same exponent. 1 and 1. Nothing else has a matching pair. So I'm just going to cross these out so it's harder to see, and it's nice and easy to see that those are
Well, what's
like.
the negative?
Oh,
and
okay.
what's not?
That doesn't matter. We're just looking at the variable and the exponent. Yes.
For the next one, I know.
Okay. Chloe wants to help us out on the next one here.
Well, the first one.
Poppy.
Is it like all of them except for 4B?
All of them except for 4b.
Because the A all have an exponent of 1.
But what
Yeah,
about
but like if it's an A and a B, then that'd be 2. Because
Yeah. So so this A and B, this one
Not
has a
that
B
one.
and this one doesn't have it. So those aren't the
But
same.
it's like the A
So,
and the
but
7A.
like the 7A, the 1.5A, and the first A.
7a, the 1.5a, and the first A. Yeah. Because those are all A's with the exponent 1. So I'll just cross those out. All right. I'll switch color. Here.
Oh,
Okay.
this makes sense.
C. What's the same?
First one.
The first one.
First one with what? So you're looking at ST.
Yeah.
Is there another ST anywhere?
There's the third and the fourth.
The third one and the fourth one? Yes. Right?
Why'd they put the hat?
So this is just a number written as a fraction. So that doesn't matter. Don't let that throw you off. That's just a fraction, right? And so this, I'm gonna cross that out, and I cross that out. All right.
Can we just do process of elimination?
You can do whatever you want that helps you. So what is our like term here? What variables are we looking at the next one?
First, second, and
JK.
JK. So you have a J with exponent 1 and a K with exponent 1. That shows there. So where else is this?
the second one.
Second one,
And the
And
fourth one.
fourth one. All right, so not this one, not this one. All right? Okay. All right. How about the next one?
Would you pick the first one and the last one? Because they both have
No. Well, the.
What do you guys think?
Wait, what was
Well,
D was those ones right there.
can it be the numbers?
Sadie?
Since they both have all
Okay.
ones.
6, negative 2.5, and negative 0.1?
Yeah.
Yeah, because they don't have.
So those are all considered terms, just all terms without variables. So it can't be this one, and it can't be those ones. Okay.
I don't know what.
Well, how about
the
this
next
one?
be both the F's.
Renee, what do you think?
Would it be F and F2?
Well, this is F, this is F2. They have different exponents, so those wouldn't work.
Then if you put the three together, then it's another.
Well, they're all separated.
They're all separated, and in fact, they're all different.
So
Yeah.
should we just cross
Wait.
them all out?
So there is no like terms here. They're all right. Don't just leave it blank. You see, if this question was like on a quiz or a test and you left it blank, it wouldn't leaving it blank wouldn't actually let me know that you understood that there was no like terms or you used to know what to do. Right? So write something.
I know.
Okay. G.
The second one, the fourth one, the fifth one.
The second one, the fourth one, and the fifth one. Do people agree with Chloe?
Yep.
Yeah. All with a P with an exponent 2. This one and this one crossed off. All right.
Obviously not the half. That's just confusing. Just
What do you think, Renee?
Would it be the half, the 0.12, and the 9?
The half and the 0.12 and 9.
Huh.
Yeah. All constants. Right? All of them without variables. So this one is R, and this one's a R squared, so those aren't alike. So one's just a fraction, one's a decimal, one's a whole number. All numbers.
So if you really wanted to, you can turn that into 0.5.
You could, yeah, but they're just all numbers, right? Yeah. Okay, now, like terms, the key thing, can be combined. All right?
So how do you do that?
So you can add or subtract the terms. Now, unlike terms, cannot. Right? So unlike terms are like this sign. Adding them up gives you a nonsense answer. Right? Like terms, we can combine them. And we just add or subtract. Right? So when combining, we look at the sign in front of it, and that helps us decide how to add it. Right? For example, so we are given this expression, and we want to create a simplified version or an equivalent version. It all means the same thing. It means combine the like terms and give me something that's more simplified. Right? So what I typically do with kids is I go, just start from the one on the left. I go, I have a 3m. And can this 3m be combined with anything else there? Do you see anything that's alike with this? Yes, Chloe.
Could you combine it with the m squared?
No, that's a different variable, right? That's an m squared. That's an m. So they
Well,
can't
then
go.
you can't.
So then both of them
Yeah, then
squares
it's the
should be
other
together,
M
right?
Yeah. Sorry.
Both of the M squares should be.
That'd be it. But we're just going through our process of elimination. So the first one, 3m. It can't be combined with anything else. Okay. So we'll write down 3m, right? And if you want, you can cross it off because we dealt with it, right? Then let's do the next one.
6.
We have a m squared.
Oh.
Okay. Do we have another m squared anywhere?
Yeah.
Okay. So this is where we look at the numbers in front of the m squared. What's the number in front of the first m squared?
Nothing.
No, there is one.
One.
Something there.
Just get one.
0.
-1.
Oh, what?
No.
That's a
Don't
subtraction
start this
sign.
again.
All right. What's the number in front of the second m squared? 3. If I were to add these numbers together, what do you get?
2. Wait.
-3 plus, no, sorry, -1 plus 3.
Oh, no, you get
-4?
Isn't it 1?
I don't know.
No, because you're
Two.
-1 plus 3, so
I
that'd be
hate
1, 2.
just stupid negative.
Hey,
It'd be 2.
it'd be 2. And if you're not comfortable, you can use your calculator.
How would it be 2?
-1
Because you're at -1, you're like 1.
Plus
2,
3.
2.
From that.
Okay.
So you're going that way.
Negative 0.
-1.
You start off with -1. You add 3 to the right. 1, 2, 3.
No.
Alright.
Charlotte, when you're counting, you don't add, so you're at -1.
You don't add?
No, you do, but you
So
don't
what
add
would it be?
negative
Would it
one,
be
so
like-
-1?
And would it be 2?
Yeah, it'd be
1.
2.
Two.
So, this is 2. -1 plus 3 is 2. Or you can think of it the other way around. Instead of thinking, if that bugs you, why not rewrite it like this? Just swap the order. Does that make it a little bit easier to see?
Yeah.
Sure.
They are both equal to the same
Does.
thing. Right? So, this is equal to 2. What are we counting?
Wait, how do we get
Wait.
Alright? We're counting m squares. Alright? Now,
But you wouldn't.
all of a sudden, we have one term with another term, nothing in between. So, when it's positive, we need to show a plus sign so we can separate the terms out. Also, it just looks like 3m and 2m squared smashed together. It isn't that. Alright? Okay. Then,
So now do you just do
so I can cross off this. I've dealt with this,
So it's
So it's
-6. And that can't be combined with anything else. There's nothing else left. A minus
that's
6.
it?
That's it. So that is its combined or simplified or equivalent expression. They all mean the same thing. Right? So just collecting your like terms and adding them together. Okay. Let's do some more together here. Just now, actually, before we go on, to add life a little bit more difficult, this next step is optional. Okay?
Well, then I'm not going to do it.
Okay, now, the convention for math, right, is when we write our expressions, we try to write it in from the highest degree down to the lowest degree. So if you look at the back of a textbook, if this is a textbook question, the answer for this would have looked like this: the highest degree term to the lowest degree term.
How is it
Okay.
the
How is
highest?
6 lower than 3? Oh,
The degree, right?
Oh, no, no.
Right. Okay, these answers are mathematically equivalent. I am not going to mark you wrong for giving you this answer versus this answer.
Okay.
But as you get into older grades, they're going to expect you to follow more and more the math convention, and that is, yeah. But they're,
Are we going to have to do this on the test at all?
no. Oh, this? Yes.
No, the,
This? No, I'm not going to force you to do that. Right? But it's something to just to be aware of. Right? Right? And honestly, like, instead of having to rearrange it at the end, what I typically do is I start off with the highest degree term and just, okay, that's the first one I'm going to collect and just go from there. Right? Instead of reading just left from left to right. But we can, because left to right makes easy. Okay, first term is a C, then exponent 1. Do you see another C? 3C. All right, so we have, once again, exact same thing, -1 and a +3.
It'd be 2C, right?
It would be 2, and we're adding C, so 2C. All right.
But it'd be the same for that other one too.
what about the minus sign?
I don't
Wait,
feel
what would you
comfortable
do?
doing this.
Hmm?
Cross out. What about the subtraction sign?
What subtraction sign?
in front of the C.
The first c? Yeah, that's the -1. -1 and a +3. All right? All right? Okay.
What would you
So-
do for the next
So I'm going to cross this off, and going up next, we have a c squared. Do we have another c squared?
one? Obviously.
Yes!
But one's negative.
And one's positive. So what's the number in front of the first one?
-1.
What's the number in front of the second one?
One.
It would be just
One.
It'd be
Zero.
It'd be zero. It'd be
Zero.
-2.
-1 and +1
So just plus
add up
C.
to be 0.
So
Would
it's
it
just
be
plus
plus
C.
C2?
No, it'll be 0 c squared, but 0 times anything is just 0. So we ignore it. We leave it
So
out.
you just read C squared?
Just, no c squared.
Or just
Because technically it would be 0 c squared, but 0 times anything is just 0. It doesn't exist, right? So it's nothing. So we just leave it out.
what?
that's it.
What? So if
This-
there's a 0, you don't write it.
If it's a 0, you don't.
0 is my best friend.
All right? And there will be zeros,
Fine, okay.
right? Unless the whole thing adds up to 0, then you pretend a 0.
It's freezing here.
Okay,
I don't know.
so if we, the next one here.
Wait, what happens if there's 3?
Oh, I
can.
don't want to do that with the wall.
Okay,
Can you add like, you know how you can add 2? Can you add like 3 or 4 too?
yeah. I'll do the first 2, then I'll have you guys do the last
No.
3.
That hurts.
No, I'll stop and come back. Okay,
No, that
we have
1.
a number without any variables. Do you see any other numbers without any other variables?
9.
Yes.
9 and 10.
9. Anything else, Kaylee? 10.
What do you do then?
All right. So you're adding
What?
7,
Plus 10 is 17.
-10, and 9 together. What does that equal?
6.
All right. Yeah, it is right.
It is.
If you can do it on your calculator if you're not sure. You go 7 minus 10. Oops, that's not right.
Wouldn't it be 3?
Minus 10 plus 9, 6. Right? Or if you want to do it just one step at a time, 7, 10 plus 6, that makes -3.
You get 6.
It's
Oh, sorry.
9.
Did I write it down wrong?
Yeah, it's
Yes,
9.
very much wrong.
9. Last number is 9. Right? 9. Then -3 plus 9 is 6. So that is 6. Okay. So across these, dealt with it, dealt with it, dealt with it. Next up,
Now it's just the ends.
ends. Are there other ends?
Yes,
Yeah,
there's a
there's
5,
three.
a 1, and
All right. So we have a 5 minus 1 plus 8. What does that equal?
a where?
Yeah, 12.
12. Yeah.
12.
So 12. And yes, Michaela, we need a positive sign between here. And am I missing anything?
The end.
The n, because we added n's. So this is 12n. Right? Okay. Okay.
Is that it?
Yeah, that's it. We've done every single one on that one. Okay, starting from the left. Now if I rearrange this from highest degree to lowest degree, it would be just 12n plus 6. Right. Okay. First term is a whole number. Do you see any other whole numbers?
8
Okay.
and 5.
No, that's got a k attached to it. It's not a whole number. -4
It'd just be 4.
and 8. What does that combine to make? 4. All right, we're done with those ones. Next up, k squared. Is there any other k squared?
Yeah, 7.
All right. So, what are the numbers in front?
-1 and -7.
-1 and -7.
Could be -8.
That would be -8. -8
Would it be -8?
and k squared. So the -8, when you put it down, it looks like a -8 then. It means the same thing. Right?
Yeah, but I don't understand that because I was always told that minus and like subtraction subtraction and negative are different.
Yeah, that
But now they're the exact same thing. And
Yeah.
It's like, I just don't get it.
Because in grade 7 and grade 8, you look at very simplified expressions and they put brackets around everything. When you're dealing with negative numbers, it would look like something like this. To make-
Yeah.
Oh, yeah.
I want that back.
Which is really nice and easy to see, and I agree with it. It's a lot more clear. However, there's a lot more redundancy to it, right? We don't need these brackets. And two negatives make a positive. So that exact same statement can be rewritten as that. Right? Means the same thing, but it's cleaner. Eventually, hopefully it gets simpler.
Well, couldn't like for that? Couldn't you just have -5 and add -2?
Why would you add negative 2?
No, you're subtracting 2, right? Right?
That's what calculators are for.
Yeah. Okay.
What about the 5K?
Then we have a 5K, and there's nothing else for it to be combined with, so it can't be combined with anything. So we just write down plus 5K. All right.
How do you rewrite that in like order?
So the highest degree would be the K squared. So that gets first.
Would it be -8?
-8, just as you see it. Then next would be the K. That has a degree of 1. Then the 4. Rewritten. Positive 4. Right, so once again, after the arrow, you don't have to do that, but it's nice if you start thinking in that sort. Right. Okay. Try the last 3. I'll give you a few moments here and I'll come around and help. People have either done this or they're completely stuck.
I quit the practice question.
All right. So let's go through this together.
Can we have a break after?
Yeah. So, first one. I got a W squared here. And I got a W squared here. And a W squared here. So I have a 1 minus an 8 plus a 7. What does that equal? Right? 1 minus 8 is minus 7 plus 7. So Poppy, this would help.
What?
Right?
Right.
So what's minus 7 plus 7?
14. Oh, wait, what?
And just equals
Negative 7 plus 7.
-7 plus. Let me go make that. 0.
plus 5.
Sorry?
0.
0.
-1 for the
Right?
and then
So-
8.
We have 0 W squares, so we don't need to write that down. Going to the next one. I have a W here and a W here. So I have a negative 3 plus a 10. What is that? What's negative 3 plus 10? Yes, Sydney? 7. And what are we counting? Is W's, so 7W.
So,
Okay. That's it. Okay, next one. I have a B squared, there and there. So I have a negative 2 and a positive 3. What does that make, Poppy?
1.
Yes.
Yay.
1. And what are we counting? What variable? B2, B squared. So, the 1 in front does not need to be shown. Right? So you can put it there. I won't mark you incorrect, but it's extra and is not needed. So just B squared. Next, we have a B here, a B here, and a B here. So negative 7 on the first one, 8 minus 8, and a plus 1. Okay? Do it in 2 steps. Negative 7 and negative 8. What does that make?
-15.
Negative 15 plus 1.
-14.
Negative 14. So minus 14. And remember to include the variable. Don't forget the variable. We're counting B's. And a B. Okay. Okay, last one. I have an A here, an A here, and an A here.
I have a question.
Yes, Chloe.
Does it matter where you start in the problem, or
Nope, you can start at any number. So I just usually go from left to right.
but can I go
When
from
I'm
right
teach-
to left?
You can go right to left. And typically when I get to the grade 10 level, when I'm doing these, I start with the one with the highest degree, because then my answer will be the highest degree to the lowest degree. Right? So I have -2, -1, and a -5. All right. So Poppy, me and you.
-8.
Yes.
Yay! Yay!
And what variable are we counting here?
A.
So include the A. All right. I'm going next one over. I have a number without a variable, a number without a variable. So I have a -1, -7. What is that, Poppy?
-8.
-8. Okay. And that's it. Awesome. Now, usually students, after some practice, get pretty good at this. One of the common errors that I may come across with a student is they'll go like this, and then they'll go -16 or -16A. You can't do that.
0A.
No, these are unlike terms. You can't add these. This is the most simplified as you can get.
How about we just don't add
That's you stop right there, right? Okay.